All right, let's talk about something really weird. We're going to talk about a force that isn't really a force. People call it imaginary or fictitious, but get this, it has the power to steer massive hurricanes, to command entire ocean currents, and to literally guide the winds that circle our planet. This is the story of an illusion that has some incredibly real consequences.
But first, we have to tackle the one question everybody asks about this thing. You've heard it a million times, right? Maybe you even saw some demonstration on a travel show that a toilet in Australia spins the opposite way to one in, say, America. It's the classic party fact. But is there any truth to it?
The short answer? Nope, not at all. It is a complete and total myth. And yeah, I know, it's a cool idea, but science, well, it has a very different story to tell.
So why is it a myth? Well, the Coriolis effect is just way too weak to have any influence on something as small and as fast as the water in your sink or toilet. The shape of the bowl, the angle the water jets come in at, those things are thousands of times more powerful. In fact, some scientist who actually put this to the test had to use a huge basin of water and let it sit perfectly still for 3 weeks just to get rid of any other currents. Only then, by draining it one single drip at a time, could they finally see the effect. So, yeah, not happening in your bathroom.
Okay, so if it doesn't spin our toilets, what on earth does it actually do? To figure that out, we need to get to the heart of what the Coriolis effect really is, this so-called apparent force. The most important word in this whole thing is right here in the definition. It's an apparent deflection. The object isn't actually being pushed by some invisible force. The curb we think we see is just an illusion, and it's created because we're standing on a spinning surface.
This quote from NASA just nails it. They say the Coriolis force is imaginary because the objects are really just moving in a straight line. The curb is what we see from our point of view on a spinning Earth. If you were floating out in space, watching a missile fly over the planet, you'd see it go perfectly straight. But for us on the ground, which is rotating right underneath that missile, its path looks like it's bending. It's all about perspective.
To really get a feel for this, let's use the classic analogy. Just picture yourself on a spinning merry-go-round. You're trying to throw a ball straight across to your friend on the other side.
From your point of view on that ride, the ball seems to curve like crazy, veering way off target. But if someone was standing on the ground just watching, what would they see? They'd see the ball fly in a perfectly straight line. The curve you saw only happened because your friend, your target, had rotated away while the ball was in the air. The ball went straight, the target moved.
So now, let's just scale that idea way up. We're going from a playground toy to our entire planet, which is basically just a giant spinning merry-go-round.
Now, here's the secret to understanding this on a global scale. Different parts of the Earth are spinning at completely different speeds. If you're standing on the equator, you are whipping around at about 1,600 kilometers per hour. But someone standing near the North Pole, they're barely moving at all.
So think about it. If you launch a rocket from the equator and aim it north, that rocket keeps all of its fast eastward speed it had at the equator. As it flies over land that's moving slower and slower, it starts to get ahead of the ground below it. From our perspective, it looks like it's curving to the east or to its right. The same thing happens in reverse if you're moving towards the equator.
This all boils down to a few simple but really powerful rules. In the northern hemisphere, things seem to bend to the right. In the southern hemisphere, they bend to the left. And the effect gets stronger and stronger the closer you get to the poles, but it completely disappears right at the equator because there's no difference in rotational speed to create that curve.
Okay, so we've established it's an illusion. It's all about perspective on a spinning planet. So what? Why does this even matter? Well, because on a planetary scale, this imaginary force has some very, very real and powerful impacts.
And I mean massive impacts. The Coriolis effect is like the master architect of our planet's entire climate system. It dictates the direction of global winds, it sculpts those huge ocean currents, it's what gives hurricanes their terrifying spin, and it's even a critical factor for something as precise as aiming long-range missiles.
Just take a hurricane, for example. A hurricane is really just a giant area of low pressure. Air from all around wants to rush in to fill that low-pressure spot. But as it rushes in, the Coriolis effect gives it a nudge. In the northern hemisphere, that nudge is to the right, which forces the whole system into a massive counterclockwise spin. And in the southern hemisphere, the deflection is to the left, which creates that classic clockwise rotation.
You see the exact same thing happening in our oceans. The wind pushes the water, but the Coriolis effect is always there, deflecting it, creating these enormous rotating currents we call gyres. These gyres are basically a global conveyor belt, moving warm water from the equator up towards the poles and bringing cold water back down.
They play an absolutely crucial role in regulating our planet's climate.
And you know what's really cool? This isn't just an Earth thing. No way. This amazing image from Mars shows these long streaks carved into the surface by Martian winds. See how they're curved? That is the Coriolis effect at work on a whole different planet. It's a universal principle of physics. Any rotating planet is going to have it.
Now, for those of you who want to geek out a little bit on the mechanics, there's this fascinating little detail hidden inside the physics that explains why the effect is exactly as strong as it is.
See, when physicists write out the mathematical formula for the Coriolis acceleration, there's this factor of 2 in there that for a while was kind of a mystery. Why is the effect this specific strength? Why times 2? It seems a little random, right?
Well, it turns out the effect actually comes from two totally different things that just happen to be equal. The first half is what we've been talking about this whole time. The object moves to a new spot where the ground underneath it is spinning at a different speed. Simple enough. But the second half is purely geometrical. As the planet rotates, the very direction of the object's flight path gets rotated from your point of view. Each of those contributes exactly half of the total effect.
As the physicist Lachazar Semyonov puts it, that factor of 2 isn't some random fluke. It's there because 2 distinct physical processes perfectly combine to create the full force of the Coriolis effect that shapes our world.
So we end up right back where we started. We have an imaginary force, an illusion of our own perspective that is powerful enough to command the winds and the seas. It really makes you wonder, what other profound, unseen principles are quietly at work all around us, shaping the world we see every single day?